It's a great honor to be here. Thanks for inviting me. My name is Dr Yoffe. I'm a PhD candidate from the Landscape Department. I'll present my research on sustainable urban landscape, a computer-aided sustainability evaluation framework for conceptual designs. This is a dissertation under the supervision of Yasha Grobman and Nina Plaut. So, increasing population growth and urbanization threatens ecosystem services globally. It increases climate impact on urban dwellers and accelerates biodiversity loss. Sustainable development of cities, which enhances and regenerates urban environments, is therefore considered one of humanity's most significant challenges of the 21st century. Sustainability rating systems are the AEC industry's standard methods for evaluating sustainability development. These systems, however, are labor intensive and suffer from low adoption and implementation rate. One research direction for bridging this gap explores the use of computational-based methods and tools. In the past decade, we also witnessed an increase in the use of quantitative big data to measure numerous aspects of urban environments' performance. So, although significant work has been undertaken in this field, there is still a lack for sustainable development evaluation frameworks, and specifically a lack in these frameworks in the context of urban landscape performance and to measure landscape development. The research aim for this study are to define sustainable criteria and data type that are most needed for advancing landscape sustainability, and then to develop a computational framework for conducting sustainable evaluation of landscapes. In the search for an effective research path to direct us on this study, we use a systematic review and a survey among the professional community. By combining these methods, we sought connections between existing supply of knowledge and big data and landscape sustainability evaluation and the industry demand for sustainability evaluation knowledge. Knowledge supply-wise, the systematic review, which covered more than 900 papers, revealed a growth in this knowledge, specifically in studies covering the urban realm and methods for studying of sustainability. Similarly, we found sustainability professionals and landscape architects indicated that the most needed sustainability criteria to be measured are ecologically related credits like runoff management or establishing urban forests, and that the urban level development projects are the most needed for sustainability evaluation solutions, specifically in early phases of the design. So the supply and demand study led us to propose an early design computational sustainability evaluation framework for neighborhood scale developments. Our proposed framework not only calculates the sustainability score of the existing rating system, but advances the method by adding spatial, composition, and configuration metrics to the design. The method focused on key performance indicators, KPIs, at the neighborhood development level. The KPIs chosen for the model represent ecological regulating ecosystem services, which on the one hand are less studied in early design phases, but also have a high positive impact on other production and cultural ecosystem services. The chosen criteria were stormwater management, heat island effect mitigation, and optimized biomass. The sustainability measurement method used for this study was the site's V2 rating systems for landscape development, and the composition and configuration indicators that were used were landscape ecology fundamental metrics such as connectivity, diversity, and edge proximity. The computation evaluation method was comprised of 3 steps: data preparation, calculation, and analysis and representation. In this example of biomass optimization, the methods compares existing vegetation conditions in the site and to the design model. A custom designed Python code calculates the sustainability scores of the matrices and sustainability criteria and generates an in-model representation of the result. In a demonstration experiment, we tested the system on Ganei Azar neighborhood design 29-hectare, 2,300 residential unit neighborhood, mixed use, in the Tel Aviv metropolitan area. So this vegetation analysis demonstrates connectivity and fragmentation of vegetation patches in the design. The visualization provides the designers with insight into the hierarchy and diversity of planting schemes of the design. In terms of stormwater management, we compared the original neighborhood design to an enhanced performance iteration. We added retention and catchment elements to achieve retention goals set for the design. And the model calculated the retention volume needed based on local meteorological station precipitation data. In this example, we see that although we achieved the design's total catchment goal, the model indicated the southern neighborhood basin, the one in red, is underserved and basically prone to flooding. The table on the right summarizes the performance for 11 matrix measured using the computation framework. Our preliminary test saw a connection between indicator behaviors. For example, increased proximity reduces patch contrast in vegetation planting. This test demonstrates a working computation framework which contributes to, firstly, enhancing the parametric vocabulary of less studied ecological sustainability criteria in the design. It enables computation benchmarking for ecological ecosystem services in landscape designs, specifically on the neighborhood level developments, and provides live feedback for the designer, which increases the implementation impact of sustainable development in the project. So in light of the research aim, this research, firstly, they defined criteria that are much needed in landscape industry for evaluation of sustainability, and it developed a computation framework for conducting this sustainability evaluation early on in the design phase. In terms of future development, this system is currently operating on neighborhood level analysis, and the future validation for the preliminary findings is needed. I'd like to thank my friends and colleagues for supporting me in this research, and thanks all for listening.